Hello and welcome back to Elementary Algebra section 7.2 on multiplying rational expressions. Well, it's also dividing, but we'll see, right? It's technically the same thing. So again, we are talking about rational expressions, which means fractions, and these fractions contain expressions with x or y or whatever other variable in them. So that means that we are going to have to factor and cancel and do all of the stuff that we have been doing previously in chapter 6. So we're going to start with first understanding and remembering basic fractions. If you have, let's say, 8 over 36, so that fraction can be cancelled by 4. So if we divide top and bottom by 4, we'll get 2 over 9. So cancelling fractions is very, very useful because we reduce numbers we work with. Now, in terms of algebraic expressions, it's also very useful because we get to work with less variables and less factors. So if you have, this is again from our 7.1, let's say if you have x plus 1 divided by x squared minus 1, you know that you can factor denominator into x plus 1, x minus 1, and then when this cancels, your answer is just 1 over x minus 1, which is way easier to work with and compute and everything than the original problem, which is why we do it. So this notion of canceling fractions is very important because it reduces, whether it's numbers or expressions, right, the number of terms and number of factors, it reduces the whole situation to a smaller value. So now we would like to take a look at multiplication. Multiplication is done across. So all you need to do is to multiply the numbers on top, multiply numbers on the bottom, and you are done. So yeah, that's all nice, right? But if you can reduce your fractions, then you have less work to do. So if you have, let's say, 14/15 times 9 over 21. This can be reduced by a lot. And maybe we don't even have to do multiplication by the time we're done reducing. If you reduce 15 and 9 by 3, you get 5 and 3. And then you realize that you can cancel 21 and 3 by 3 and get 1 and 7. And then you realize that you can cancel 7 and 14 and get a 2. So the entire thing is just 2/5 without actually having to compute anything. So if you kind of follow the colors, right, you can see that, right, we canceled the red ones first, and then we canceled the blue ones, and then we canceled with the green at the end, and everything reduced down to 1, right? So over here, technically what you have is this, which is just 2/5, right? If you want to write that step in. So it's absolutely amazing, right, that we can reduce fractions and numbers to the point where we actually don't even have to compute. It's just here, done. Now, obviously, that's not going to happen every time. So in some cases, right, we would have to multiply because nothing would cancel, in which case you just go across. So this problem was great because it was something that we can cancel, but you might have 2/7 times 5/3. And in this case, nothing cancels, so you just have 10/21 and you move along because nothing cancels. So that happens in some cases as well. We don't get to pick and choose, right? We get to work with whatever is in front of our nose. So let's go and now talk about the topic, which is rational multiplication of rational expressions. So we're going to do the same thing as we did in this fraction, except now we're going to have x values and so on. So x plus 1 divided by, let's say, 3x squared times, let's say we have x plus 3 divided by x plus 1. So we hopefully see fraction times fraction. So that definitely fits what we are learning today. And now what we need to do is cancel what we can. Well, in this case, 1x plus 1, that it's on the top, right, the numerator, and 1 from the bottom, which is denominator, they cancel each other out because they represent the same value. You see, x plus 1 is some kind of number, right? If you tell me that x is equal to 5, right? If x is equal to 5, then the whole thing here is 6. So that would be a 6, and this would be a 6, and then they cancel. So if you have two identical, right? If you have two identical factors like this, they get to cancel each other out completely. Same happens here, where you cancel this x with one of the x's from x squared, right? When you have x squared, it's x times x. So when you cancel one of the x's, only a single x, which is single x stays, which is why we can just cancel that square up there, which kills off an x. So now what's left? It's x plus 3 divided by 3x. And we're done. There's nothing else can be done. You can't cancel 3's, you can't cancel x's, because these are actually different numbers, right? Just put x equals 1. You get 4/3. That doesn't cancel. Right? Put x equals 2. You get 5/6. That doesn't cancel. So, placing the value for x, you see that as long as you're able to find one case when it doesn't cancel, that means that algebraically they don't cancel. All of these things are, in the end, numbers. And if you're ever wondering if you can cancel something, you can just make, let's say, x equals to 2 and see if it would cancel. Or try an x equals 7 and so on. I mean, we're bound to find something that might cancel somewhere, somehow. But, I mean, any multiple of 3, yeah, we can solve this. And you can make it into cancel into anything you want, actually, but whatever. But this is the essence of what we are learning. This is the essence over here, meaning that we are canceling identical factors, and then those factors get canceled, and the remaining factors stay as the answer. So what are the steps? Number 1, factor. Number 2, cancel. Number 3, win. That's it. That's all it is. So now we are going to take a look at some of these exercises. So here is the one where we have to do some work. I'll present 2 more examples, and then I'll put some of those for you guys to work out. Now, if you feel like jumping in right now and helping me with this, that's perfectly fine. We see the steps. Factor. Well, the only thing we can factor is this one. Can anyone tell me what that factors into? Come on, don't be shy.
Would it be x squared minus 4 over x plus 2?
No, I'm asking what this factors into. What are the factors of this? I'm asking for chapter 6 to factor
okay.
in. Come on, guys. This was on the exam last 3 days ago.
Sorry, would it be GCF or a special one? I'm trying to remember.
It's a special one.
Is it going to be like x plus something, x minus?
Yes.
Is it, let me see, 2?
Yeah, nice.
Perfect squares, right? Okay.
X minus 2, x plus 2. And then we have x plus 3 times x plus 3 over x plus 2. Awesome. So now you see that x plus 3 has a pair. That cancels. Then the blue pair cancels. And the only thing we're left with is x minus 2 as the answer.
Wow.
Great. One more example, and then I'll put some examples from the book and the homework. So again, if you guys want to contribute here, that's awesome. Okay. So again, factor everything you can, then cancel, and then this is the win part, right? When you have your answer correctly displayed. So what kind of factoring can we use in this particular case?
Oh crap, isn't it x raised? It's the second one we learned or the third one? It is the third one.
Okay, so what are the factors of 2 and how to make 3?
Exactly, yeah. Okay.
Yep. So if both of these are positive, they will multiply into positive 2, which is good, and they add into positive 3, that's good as well. So we are done with the first factors, x plus 1, x plus 2. Now the second one is hopefully easier because the factors of 1 are just 1 and 1, so x plus 1, x plus 1. And now we cancel the numbers and we cancel x plus 1. Right, so those are the pair of identical factors, which we can cancel. So what's left? X plus 1 divided by 2 times x plus 2. And that's it. These problems are very, very easy if you know factoring from chapter 6. Now, if you struggle with factoring, obviously this chapter is going to have a lot of problems. So the hope is that you know factoring from your previous chapter. So now the time for you to try some of these exercises. I'm going to jump into homework and see what they have. There we go. So we have this. We'll put 2 5x squared plus x divided by 2x minus 1 times 1 over x. So that will be first problem. And the second problem is z squared minus 9 over z minus 5 times z minus 5 z plus 3. All right, so I'll give you a few minutes to work on this, and if you are done, you can just start talking, right? Is anyone done? I mean, this should go quick if you know basic factoring.
Honestly, I'm a little confused.
All right, let's discuss the problems then in that case. So we are using basic factoring from chapter 6 to break down each one of these factors down to break each one of these expressions into basic factors, and then we're just canceling the pairs that are identical. So looking at this one, it is GCF. So
Yeah.
we kick out x, we get 5x plus 1 divided by 2x minus 1 times 1 over x. And the only thing we can cancel is just x and x. That's it. Nothing else works, because this is 5x plus 1 and this is 2x minus 1, completely different animals. And this is what we're doing for every single problem. There are no extra steps, tricks, literally nothing. You look at the problem as a whole, realize that there are 4 different compartments on this problem, and in this case you realize that the 3 are already done and factored, so nothing to do there. All I need to do is to factor one of these that is not that can be factored using the GCF. So the only thing I can factor is this one using GCF, and I'm using GCF because that is the appropriate technique. Again, you need to know all 4 techniques from chapter 6 and then use whatever is appropriate for that particular case. So in this case, GCF was the appropriate one, and we factor out x. You're left with 5x plus 1, and then you just see, oh, I can cancel that x because I have 1x on the bottom and 1x on the top. Does it make sense?
Yeah.
Awesome. So now let's go and take a look at the second problem. I'll give you some time. Go through it. Let's see what we get. Any suggestions?
Z squared minus 9 can be factored like a perfect square, right?
Yep. The square, the difference of squares, yes.
Oh, okay.
So what should we write?
Z minus 3, Z plus 3.
Excellent.
One quick question. Does the order matter or does it?
No, because multiplication. So you can put plus first and then minus, or the other way around, because multiplication is commutative. Good. And now what do we do with this?
Z minus 5 cancels out.
Excellent.
So the answer is Z plus 3.
Anything else canceling?
Oh, the other side. Oh, okay. Z plus 3 cancels out.
Okay. And
So
our
Z.
answer is
Okay.
just Z minus 3. That's it. Guys, that's it. Factor cancel done. Factor cancel done. Factor cancel done. Let's see if they have another one. This one is just a little bit more annoying than usual, but still. So t plus 1 squared divided by t plus 2 times t plus 2 squared over t plus 1. Do we need to factor anything here?
Do we have to distribute the 2?
Oh, that will make it worse, actually.
Oh, okay.
Because right now it's already set up for factoring.
Oh.
Right? It's already set up. There's nothing to do other than say, okay, t plus
so
2
it's T plus 1 over.
Yeah.
Wait a
Yes.
minute.
T plus 1 times t plus 2. That's it. The denominators canceled completely in this case. All right, one more, and then we're going to move to division, which is more of the same, actually. So y squared minus 4y divided by y plus 1 times y plus 1 divided by y minus 4. Any ideas? Hello, you still awake?
Yeah, I'm thinking.
Okay, thank you. I was concerned for a moment.
So
Mm-hmm.
always something to factor, at least for these examples. I'm trying to think if I just cancel y plus 1 first, or do you have to
You can
factor
do that.
y?
You can do that because if you cancel y plus 1 first, your problem now becomes more obvious on what to do next. Because now your problem looks like this. So now you're not canceling two fractions, you're only canceling one fraction. And the question is, what do we do, right?
So is it y minus y? Wait a minute.
Tick off all of the methods that we have for this and then pick a method that is appropriate for the situation.
Oh, could we do, let me see. We do y minus 2 plus, sorry, y minus 2, y plus 2?
Nope, that will give you y squared minus 4. But then there's this y missing, right? So if you write y minus 2, y plus 2, that would factor into y squared minus 4. But you don't have minus 4, you have minus 4y. And that tells you something about the problem.
Right.
How do we factor, guys? Right here. How do you factor this?
Oh, would it be GCF?
Yes!
Okay.
Right? So
Yeah.
we kick y out. We got y minus 4 divided by y minus 4. These guys completely cancel. And the answer is just y. Now, this answer is so cool because if you are to compute this at, let's say, y equals to 10, you would get 10. Whatever y you pick, this is how cool this problem is. No matter what y you pick, positive, negative, fraction, decimal, it doesn't matter. Whatever you pick, when you compute this entire mess here, you will get the number you started from. So you can use it to troll people if you want to. You have my permission and support as well, right? The more trolling, the happier the society. That's how I look at it. A public service announcement, right? There we go. And now we talk about division. Now, for fractions, division is done through multiplication. So your job is to flip the second fraction, and then you just multiply across. So there's the flip. You flip the second fraction, and you change division into multiplication. So when you do that, right, when you do that, you guys have immediately turned your division into multiplication, and you can just multiply across or cancel, do whatever you need to do to solve the problems. So believe it or not, that's it. So now we'll just take a look at a couple of examples of division. So you have 5 over 2x divided by 10 over x minus 4. Now, your first steps now is number one, flip. Not flip out, flip. Right, so flip the second fraction. So number one is flip. Then the second one is factor. Then the third one is cancel. And the fourth one is win. So those are your steps. Following the steps, we do the flip first. And then we do factoring, where there's nothing to factor. These are all the simplest. And then it says cancel. Well, what can I cancel? I can definitely cancel 5 and 10, get a 2 over there. So the whole problem works out to be x minus 4 over 4x, because we have to multiply by that 2. So 2 times 2 is 4. Another division problem. This one is spicier. X squared minus x divided by x squared minus x minus 2 divided by x minus 2. Flip, factor, cancel, win. Okay. Flip. So that was a flip. And now we need to factor these, so hopefully we can cancel some of the expressions. What type of factoring do we have right here in the numerator? What kind of factoring, guys? Come on. It's not a trick question, I promise.
Is it the difference of squares?
Do we see another square so you can say plural of squares? Aha. Okay. So
the GCF?
Yes, you always check GCF first. That's the deal. So I'm going to copy everything that it's not going to change here. And now we need to factor this one. So I need negative 2, 1 and 2. And how do I make negative 1 out of these numbers? I can sense the disturbance in the force. Yeah. I have no clue how well you did on the test, guys. If you are not answering basic chapter 6 question on a basic factoring. All we need to know is how to make negative 2 when they multiply and how to make negative 1 when they add. Where should I put signs and what signs I should use? Is 1 positive or negative? Is 2 positive or negative?
Oh, 1 is positive.
1 is positive, which means that 2 has to be negative in order for them to multiply into a negative value. So I have
X plus 1, X minus 2.
x minus 2. Good. And now we're looking for pairs to cancel. So which pair should I cancel?
X minus 2.
Very good.
And X.
And x. We'll do that blue. And the leftovers are x minus 1 over x plus 1. And again, you can't cancel these, right, at all. There's nothing you can do here because they are different numbers. See, if x is 10, then you have 9 over 11, and that doesn't cancel. So we have to be very careful, right, on what we can and what we cannot cancel. All right, let's go and take a look at another one of these. So now something from homework, and hopefully you guys will practice. Y squared minus 9 divided by y squared minus 25 divided by y plus 3 divided by y plus 5. All right, let's see. Flip, factor, cancel, win. Let me know if you have anything that you would like to share as a result or a question or anything.
So it's y minus 3 over y minus 5.
That's the answer. Yeah, good.
Okay.
So we have y minus 3, y plus 3 divided by y minus 5, y plus 5 times, and we have to flip this one, right, because we changed division into multiplication. Now, y plus 3 and y plus 3 are gone, y plus 5 are gone, and the result just stays there, right? Y minus 3 over y minus 5. Good. That was the problem in the textbook. Problem number 59. Let's take a look at, how about 62? X minus 4 divided by x squared plus x divided by 5 over x plus 1. Well, let's at least flip. Is there anything that we can factor
Yeah.
or cancel?
X squared plus X.
Okay, so what should I kick out?
I'm sorry, so it's X times X plus 1,
Beautiful.
and then cancel X plus 1.
Okay.
So X minus 4 over 5X.
Beautiful. Yes. That's it. That's it. Now, we have the one that looks a little bit weird. So t squared minus 1 divided by t squared plus 5t minus 6. Everything divided by t plus 1. This is still division problem. It looks weird. Is there anything we can do to make it look more in line with previous problems? Or if you want to, you can go directly to step 1 and go from there.
We put it over 1.
Nice! So you add over 1, and now you can go and use the same methods of flip and then factor and then cancel and then win. What should we write as factors?
Well, for the bottom, you have t minus 1, t plus 6.
T plus 6, that's great. And what do we have for the numerator, which should be, I guess, easier?
1 and -1.
Yes, 1 and -1, so you have those t minus 1, t plus 1 because it's difference of squares. Okay, so now what?
You can cancel t plus 1.
Nice. Anything else?
T minus 1.
T minus 1, awesome. So the answer is just 1 over t plus 6. Good. One more, and that's it. We'll do the summary. So this one is z squared. I can actually change it. Nah, well, let's leave it z, so it's confusing actually with 2, so you get to cross your z's. Z squared plus 12z plus 27 divided by z squared minus 5z plus 14 divided by z plus 3 z plus 2. So this is up there in a spice level for elementary algebra, obviously. Intermediate algebra, you guys have to repeat all of this stuff and then add more things to it. Any ideas on factoring?
Yeah.
All right, so
I forgot what it's called, but it's the one where you look at the factors that go into like 14 and 27.
mm-hmm. Very good.
Oh.
So 27 factors are 1 and 27 and 3 and 9, and nothing else works. And factors of 14 are 1 and 14 and 2 and 7. So who can tell me what could I use to break these apart?
Z plus 3 and 3 times Z plus 9.
So both of them positive because they need to add to 12, right?
Yeah.
So Z plus 3, Z plus 9. Great. How about the one on the bottom?
Z minus 2, Z plus 7.
You need negative 5. If you have plus, so minus 2 and plus 7, that's going to give you positive 5. We need a negative 5.
Oh, okay.
So what should we do?
Plus 2 minus 7.
Yes. Z plus 2, Z minus 7. Okay, cool. Anything we can get rid of in this case?
Z plus 3.
Mm-hmm. Very good. Z plus 3 is gone.
And Z plus 2.
Yes. Z plus 2 is gone. So now we have our answer is just the leftover, which is Z plus 9 divided by Z minus 7. There you go. Awesome. Any questions, concerns regarding this section 7.2?
No.
No. They're all the same, guys. Your job is to factor, and when you factor, you cancel. And just the leftovers are the answer. If you have squares and things like that, you just make sure you remember that whatever is there, it's repeated, right? So you can cancel one of them and leave the other one. Maybe you can cancel both of them. right? So there are multiple ways in which these problems can be solved, but always the single one answer at the end, which is the most simplified answer you can find. Okay, well, let's say bye to you.